Hello, good morning, good afternoon, good evening. My name's Mr. Mlenga Kunta, the science teacher, as well as the mathematics teacher at Our Lady School in Lusaka. Well, I'm back again with mathematics, and want us to look at what are called the linear inequations. These linear inequations are also called linear inequalities. Now, most of the times, according to the ECZ syllabus, linear inequations or linear inequalities come most of the times in paper 1. However, their applications also come in paper 2 in the topic we call linear programming. So that itself gives us a reminder that this is a very important topic that we have to understand from both the paper 1 as well as the paper 2 angles. Now, well, what is it that we need to know about inequalities? What are saying these are mathematical, we can call them mathematical, or you can call them algebraic expressions. These are called the mathematical or algebraic expressions that have the following, any of the following symbols, that have any of the following symbols or signs. Okay, so these are mathematical or algebraic expressions that have any of the following expressions. One, the expression that the symbol that is used is this one. It's something that we know. This one is called greater. It's called greater than. Greater than. Okay. Now, if this is a greater than, then we also have another one which looks slightly similar to the greater, but it has another line drawn beneath it, and this one is called greater than or equal to. Greater than or equal to. Greater than or equal to. The third one is the opposite of greater than, which is drawn like that. Well, what is this called? This is called less than. Okay, so this is called the less than. So if you're going to have a symbol which looks like less than, having another line drawn underneath it, it is going to be called less than or equal to. So we have another one which looks like that. This one is called less than or equal to. Less than or equal to. This one is called less than or equal to. So those are the four symbols that are very important in equalities. One, we have this which goes greater than, having another line drawn underneath it, greater than or equal to. This one is less than, then having a line drawn underneath it is called less than or equal to. So these are the very important symbols or mathematical signs that we'll be dealing with. Wow, since we're talking about linear inequalities, meaning these ones inequalities that when plotted on an x or y plane, the type of a line that we're going to have is a straight line in form of a line. That's where the linear is coming from. So if that is the case, what do we know? What do we need to know about linear inequalities? The other thing that we need to know is that if there are linear inequalities, we can say that they all obey the general formula. Obey the general formula. But the general formulae actually are two. So I'm going to give you both of them with much of specification. So the first one is y minus y1 equal to m over x minus x1. Okay, so that is the first general formula. Now, what are those parameters that are in there? This is the y coordinate. This is just a coordinate. No, this is a variable. This is a variable. This is a y variable. This is a coordinate. A coordinate. This one here is the gradient. The gradient, this x here is the x variable. Is the x variable. Then the x1 is the x coordinate. So these are the most important aspects that are there. So you're saying the linear, the inequality you're talking about is the linear inequality, then it must obey this general formula. That was the general formula, say it's y minus y1 equal to m outside the bracket, and then x minus x1. But what are these letters standing for? The first letter y standing for a y variable. Then the y1 is talking about the x, the y coordinate. The m here is a gradient. I'll explain to you later how we can find the gradient, which is just a steepness of a line. Then the first x is called x variable, and then the x van is called x coordinate. So, what is the second formula, the general formula? These tips that I'm going to give you are very important. Some mathematics teachers do not give notes. I prefer to give notes because these notes are the ones that will guide you to solve questions. All right? So the other general formula is y minus, y is equal to mx plus c. It looks much simpler. Y is equal to mx plus c. This one I've got. So if I'm to specify these ones, this is a y variable. A y variable. Okay, this is the same gradient. This x is an x variable. Then this c is a y intercept. In here, we can see the difference that in here we don't have a y-intercept. In here we do. That's a y-intercept. Here we only have x and y variables, no coordinates. In there, we have both x and y coordinates. So these are the two important general formulae that we'll be using every now and then. When and where, that is not what you should worry about for now, because I will give you every information that you need to have. So because because the m, which is the gradient, is appearing on both aspects, the first general formula as well as the second one, therefore it becomes important for us to understand how to deal with the gradient. Now, linear, remember what I told you to say, linear inequality is an inequality which, when plotted on an x or y plane, perhaps some of you do not know an x or y plane, we're talking about the Cartesian plane. The Cartesian plane, which is having both the x as well as this is the y-axis and then the x-axis meeting at 0. That's why it's called x or then y plane. Why it is plane? Because this is plotted on a flat sheet of paper, on 2 dimensions, if I'm to put it that way. 2 dimensions, y as well as x. There isn't any other dimension pointing towards us. It's flat, so I'm using the word plane. So when plotted the inequality which has got such features on an x or y plane, the line, the type of line is a straight line. But be reminded that when you're drawing a line, you don't need a single line, a single point rather. You need more than one point. Why? Because if I'm to ask you to draw a line passing through that point, there's too much ambiguity. We don't know where the line goes. So it's always important that we need to have the minimum of 2 points. You need to have at least 2 points so that it becomes easy to join those 2 points. But if I just give you 1 point and ask you to draw a line passing through that point, a lot of lines can be drawn because they will come from different directions. There is no specification of how the line should move. All right. So if these are the tips that are important, then we're getting there. But now, be reminded that when you're dealing with inequalities, look at the general formula that I gave. This one has got an equal sign. Even here, we have an equal sign. But for it to qualify to be an equality, it should contain something other than that. Which one should it contain? It should contain either greater than, or less than, or equal to, or greater than, or equal to. But be reminded once more that we are talking about lines that should be drawn on an X or Y plane. But those lines are different because we've got a lot of lines. We've got what we call center lines, we've got lines that we call outlines, we'll have got lines that we call hidden details lines, which are also called dotted lines. So we need to understand what type of a line that is required of us to write or to draw when we are confronted with a specific type of an inequality. So with all that said, therefore, I'm going to give exam tips that will contain the type of this or the symbol, the type of a symbol, or the type of a symbol used, and then if you're given a symbol and the type of a line that you're supposed to draw. So if you are given either greater than or less than, the type of a line you need to draw is a dotted line. Is a dotted line. Moving from where to where, we have not yet started looking at that. But be reminded that when you're given either greater than or less than, the type of a line that you're supposed to draw, because talking about linear inequalities, the line you're supposed to draw should have a dotted line. All right. If you get to have greater than or equal to, or less than or equal to, any of the two, the type of a line supposed to draw is a full line. Use outline because you can have a faint line, which is also called construction line. So no, let me use the word outline. Yeah, it's okay. I can use full line. Meaning it should not be dotted, but it should be a straight line. Okay, I think these tips are enough. Now, for my students that I teach mathematics, I will remind you that this subtopic rather, inequality, it's just a build-up of what we call coordinate geometry. Coordinate geometry is a topic that is taught in grade 11. So, I'm going to believe that you have that prerequisite knowledge because you need that knowledge to deal with such inequalities. Okay, but if you are new to this, you have never attended, you've never watched my video, you've never attended my lesson before, I'm going to remind you of what is called coordinate geometry. Because coordinate geometry has got many parts. We talk about this, the equation of a straight line, talk about the middle point, you talk about how to find the gradient, and things like that. That reminds me how we can find the gradient. How do we find the gradient? Finding the gradient, like I had said, for you to draw a straight line, you need to have the minimum of 2 points. So let me take an assumption that we have 2 points. This line is joined by having 2 points. So this is okay. Let me not do that. Let me put something that we're going to understand, both of us, both parties, me and you. So if it is the y-axis and this is the x-axis, we have a line drawn on an x or y plane. A straight line, for that matter, not a curved line. A straight line. So if you have a line drawn in that way, let me call this is point 1. But remember, if the line is drawn on a Cartesian plane, is denoted by the value of x comma, value of y. But because this is point 1, I'm going to call this x1, y1. Then I have another point 2, point P, point 2, where the line is going. So let me say it's going in that direction. But because this is point 2, I'm going to have the value of x here, which is x2. So I'm going to have x2, comma, then the value of y here, I'm going to call it y2 because we have the first y here, and then the y2 right over there. So if this is a point, if these are the 2 points that we have drawn by that line, then how do we find the stiffness of the line, which is called gradient? So I need these points because these are the points that I'm going to determine. That are going to help us determine the stiffness of the line. So finding the gradient, we say M is equal to y2 minus y1 over x2 minus x1. That's how we can find the gradient. So you subtract the value of y1 from the y2 over the x1 from the x1. The x1 from the x2, that will give us the gradient. How you can tell the type of a symbol that was used to draw that line, because it is an outline, is it greater than or equal to or less than or equal to, that will come later when you start looking at it, how to shade. All right, so let me give an example. Now, before I get to the example, let me give you another important tip. So I'm going to call it exam tip. What is this exam tip? This exam tip is there to remind us on how to deal with inequalities. If you're given a situation, x is greater than or equal to 4. We are told to shade, because that will be the next thing we'll be dealing with. You are told to shade the value of x, the values of x that are greater than or equal to 4. If this is your 4 now, I'll come here in a separate part. If this is your x and this is your y. This is your y here, then this point here is 4. They ask us to shade the region where the values of x that are greater than 4 are lying. You need to understand that this is 4. So once we draw a line cutting the x-axis like that at point 4, then we're going to ask ourselves to say, on which region, is it this side on the left or on the right hand side, where we have the values of x that are greater than 4, to find that the values of x that are greater than 4 are on the right, because that's what we've got positive big numbers that are greater than 4. Therefore, we are going to shade the side we do not want. We are going to shade the side which does not agree with the statement that we're given. So with all that said, I'm going to give you now the tips. These tips are, number 1, about shading. How we shade the region. Okay, so the tip number 1 is always we shade the described region. Like the way the question came, x is, I believe you wrote it down, x is greater than or equal to 4. 4 itself is part of the solution. Why? Because 4 is equal to 4. Saying those numbers that are greater or equal. So 4 is equal to 4. We can talk about 5 because 5 is greater than 4, but not anything smaller than 4. So when you're told to shade, we're going to look at the inequality that is given. If they say shade, if I say we're looking for the values of x that are greater than 4, therefore we are going to shade the region that we want. The region that we want is the number that are greater than 4. Therefore, the other side, which is not described, we're going to the one that we don't want, we're going to shade. Or maybe let me rephrase the statement, or we shade the unwanted region. I think maybe this one makes more sense. Shade the unwanted region. like the way I brought it. We had the region looking for the values of x that are greater than 4. Therefore, on the left-hand side, where we had the values that are less, we shaded that because that region we do not want it. All right, today I think I can start with the how to shade. How to shade. Then later in the week, I'm going to send you another video. I'm going to upload another video which will contain solutions of various examination past papers. I think that will be my focus. Every now and then, I'll be going through topic by topic. So once this topic is done, then we're going to look at questions that have come in various past papers from about 2016 up to 2019. We're going to solve them all while showing you the procedure and every information that you need. Perhaps this will be a good start for many of you students. So we can look at the example. Use construct the inequalities. Construct the inequalities that describe the region R. That's a very simple question. Construct the inequalities that describe the region R. What is the plane looking like? This is what is it looking like? This is x and this is y. So let's say we have 1 here, we got 2, we have 3 here, we got 4, we got 5, we got 6. Let me extend it to negative. Negative 1 here, negative 1. Oh, sorry, you can't see. Okay, so I'll draw it a bit up so that you'll be able to see. So this is our 1, this is we put the numbers in the way that you can see. Sorry about that. So this is 1. This number is 2. Sorry, you can't see. Okay. Sorry about that. All right. So this is 1. This is 2. That is our 3. This is negative 1. Down here, you can also have negative 1. Then the inequalities, no. The scale is very bad. So this is 1 here, this is 2, this is 3. Then the inequalities will be, the lines will be drawn for us. Our duty will be constructing the inequalities that were used to plot such lines. Okay, so I'm going to have a line that will go like that. I'm going to have this line right over here. I'm going also to have another line drawn like that. Also going to have another line drawn like that. Then I'm going to have another line drawn within the x-axis. Then the shading is done. These are questions come in paper 1. These are questions come in paper 1. You need to pay attention to the question that is before us, because all those tips that I gave out, will be combined in finding the inequality. I believe we have got ideas on the topic that I earlier alluded to, which is called coordinate geometry. So now, how do we deal with such a question? Which says construct the inequalities that were used to describe that are there to describe the region R. Region R is here. It's bounded by 3 lines. That gives us an assurance that the inequalities we are looking for must be 3, because 3 lines are drawn. But how do you go about it? The first thing you need to do, give yourself the numbers to these lines, so that even when say you are solving, you are finding the inequality that was used to plot line number 1, it is going to be easier for you and I to know the line that we are dealing with. So this is line 1. This here is line 2. And this line which was used when shading down here, I'm going to call it line 3. So for the sake of simplicity and the logistical manners, I'm going to be solving these inequalities following the numbers itemized. So I'm going to deal with the first number here, the number 1. So what is the inequality that was used to draw this line? Okay. The first thing you need to ask yourself is, remember I gave 2 general equations. I'll remind you again, the general equations were y minus y1 equal to mx minus x1. The other one was y equal to mx plus c. But which one of the 2 are we going to use? Any of the 2 can be used, but the first inequality is a little bit involving. So we're going to use inequality number 2. Why? I'm going to explain. This I said from the previous writings, I said that is the y-intercept. What is the y-intercept? The y-intercept is a point at which the line you are dealing with is crossing the y-axis. I'm going to repeat that again. The y-intercept is a point at which the line that you are dealing with is crossing the y-axis. Okay? Just a minute. Right, back. So, if you look at this line, it's crossing the y-axis at the point 1. Therefore, our y-intercept here is 1. If you look at the inequality number 2, or line number 2 is crossing the y-axis at point 2. Therefore, the y-intercept, which is c, is 2. This one here is only mentioning the y-axis. This one is only cutting the y-axis, not cutting the x-axis at any point, because it is along the x-axis itself. Therefore, we are not going to use any of these 2, but I'm going to show you how to deal with them. So, dealing with equation number 1, we're going to find first thing. So, because we know the y-intercept, this qualifies to be the formula we're going to use. All that said, we need to find the gradient. But how do you find the gradient? You need to identify 2 points within the line you're dealing with. Those 2 points should have the coordinates known. Remember, the coordinate is denoted by the x and then the y. Those 2 points, choose any that you want. I'm not going to tell you how. You have to choose any that you want, but provided you know how to get their coordinates. So, if I'm dealing with this line, my points will be here. The other one is here, because I know I can find the coordinates of these points. And which one becomes point 1 between the 2? It's entirely up to you to decide. You can decide any, does not affect the answer. So according to my personality, I'm going to identify this to be point 1 and this to be point 2. So this, which is point value, what are the coordinates? The x value is 0. Along the y-axis, the value of x is 0. So at this point, x is 0, and then y is 1. So 0, 1. The value of y here is 1. Point 2, the value of x now is -1. Okay, so point 2, the value of x now is -1, the value of y is 0. Along the x-axis, the value of y is equal to 0. So these are the points that I have. It becomes easier for me to find the gradient. I just need 2 points. But because this is point 2, x2, y2. Point 1, x1, y1. So now, let me find the gradient. Find the gradient, which I'm just going to substitute. This is a variable, we don't substitute. This is a variable, we don't substitute. So don't think you're going to substitute the gradient and the y-intercept. But we know that the y-intercept is 1. Therefore, we're going to say the gradient is equal to y2 minus y1 over x2 minus x1. So our y, this is x, this is y. So our y2 is 0 minus our y1 is 1 over our x2 is negative 1 minus the x1 which is 0. So the answer here for the m gradient is going to be 0 minus 1, negative 1 over 0 minus 0, negative 1, and the answer gets to be 1. That is my gradient. So if I know my gradient, I know my intercept, then it becomes easier for me to know how to find the equation of a straight line, the equation for now. So I'm going to say y is equal to what is my m? My m is 1. Then what is my x? X is a variable you don't substitute. The plus, what is the y-intercept? The y-intercept here is 1. So plus 1. Therefore, the equation of y is equal to 1 times x, which is x plus 1. This is the equation that was used to draw this line. Look here, we are dealing with the inequalities. That is the equation. But having found that, we're going to remove that. Then we substitute with any of the inequality signs that I gave you. But which one are we going to use? This point is very critical and important. Describe the region R. So within the region R, identify any points. This point we're going to use here, we're going to identify to be used to test for the line here, also testing for this line, also testing for this line, because it is within the region. If you want, you can have multiple points within the region, but for the sake of I'm not wasting time, just use one point. That point is going to be used to test the inequalities that were used for drawing all these lines. So according to my judgment again, if this is one here, I'm to take it there, this is also one, they are meeting somewhere here. Okay, they're also meeting somewhere here. Therefore, 1,1. No. This is within the line, so I can't use that point. Okay, so I'm going to say this point here and this point here. If this is 0, this is 1, so this is half for x. And if this is 0, this is 1. I'm going to okay, so I'm going to here. So this is between 0 and 1, which is half. Between 0 and 1 is half. So the point I'm using is that point there. So the point I'm using for testing is half, half. It's not only half, half. Any point that lies within the region can be used. So I'm going to test that. So remember, this is for x and this is for y. So we're saying for y, we have half. We know that half is 0.5. So I'm going to put 0.5 equal to x again here is half, which is 0.5. So 0.5 must be added to 1 because the value x must be added to 1. So we're going to say 0.5. The 0.5, then when you add this, the 0.5 plus 1, you're going to have 1.5. Don't put an equal sign here. Then ask yourself, for those signs that I gave you, which one fits the instruction? You find that this number here is big. Therefore, the 0.5 is less. So that is the sign which was used. Is it? No, because the type of the line here is an outline. Because the type of the line here is an outline, therefore it must have O equal to. Then get that sign, remove it, and substitute in the equation that we found. This is just there for the proof, or for us to test the sign that was used. We've already found the equation, but for it to be qualified to be called an inequality, we need to find the sign, and that's what we did. So I'm going to say, therefore, the inequality which was used is y less than or equal to x plus 1. This is the first inequality that was used to draw a line. Okay. So I'm going to solve even for equation 2. I'm going to solve even for equation 2. I'm going to solve even for equation 2. So you can pause a video and copy this down before you go to the next one because I'm going to wrap. So pause it now, write it down, then when you're done, resume. So I'm going to wrap this. I'm going to wrap this. I'm going to wrap this. So if you look at equation 2 also, the line is passing through the y-axis, which is 2. So therefore, the y-intercept is 2. But do not forget, the point that we used here is 1. So 1 half, comma half, which is 0.5, comma 0.5. Those are the same points we're going to use to find the inequality which was used for shading this line. So because we know the y-intercept, therefore we're going to use this one again. Identify n2 points, like I said, within the line. So the point I've identified is here and here. Which one becomes 0.1? Which one is 0.2? Is for you to decide. I'm going to decide this will be 0.1. What is the coordinate? What are the coordinates here? The x is 2 because it is along the y-axis. The y is 0. So my point value is 2, 0.1. Then my point 2 here, my point 2 here, the x is 0, the y is 2. So the point 2, the x is 0, and the y is 2. I have identified the points. So I can find the gradient. It's very simple. Be positive in the way you are doing things. So I'm going to say my gradient is equal to y2 minus y1 over x2 minus x1. So what is this? Is the value of x, x1, x2. Then this will be y, y1, y2. So the y2 here is 2 minus the y1 is 0 over the x2 is 0 minus the x1 is 2. Okay. So we find that when you subtract 0 from 2, you're going to have 2 over, you subtract 2 from 0, you're going to have negative 2. And therefore, the gradient is when you divide here, you have negative 1. I have found the gradient. I just need to substitute with the intercept. What is the intercept? The point at which this line we are dealing with line 2. So now this is line 2 is crossing the y-intercept at point 2. So I'm going to say the equation is y is equal to what's our m? Our m is negative 1. So negative 1 multiplied by x plus the intercept here is 2. So I'm going to say y is negative 1 times x, which is negative x plus 2. So this is the equation that was used. But we're not dealing with equations. We're dealing with inequalities. Therefore, we need to find the inequality. How? We go back to what we did. Find the point. Identify the point that you got. The point here is half, comma half, which is 0.5, comma 0.5. So this is for x here, and this is for x. So where there's y, I'm going to put that, which is 0.5 here, equal to where there's x, I'm going to put 0.5, but the 0.5 is negative, so that is negative 0.5, then plus C2. And you will find that 0.5, if you bring it down, equal to the 0.5 half plus the negative half plus 2 is the same as removing a half from a 2, and you're going to have 1.5. So remove this part because these guys are not the same. You will find that the 1.5 is bigger than the 0.5. So therefore the 0.5 is less. But look at the line we're dealing with. It's a full line. So therefore, or equal to. After that, we're going to now remove the plus. We remove the equal sign from the equation that we identified using the general equation and put that. So therefore, the equation, the inequality is y is less than or equal to negative x plus 2. It's very simple. That is how we can deal with the situation. So now, the other thing that I'm going to, we are many with the third one. third one. The line is passing through the x-axis, but the shading was done. This one is very simple because we only have one variable which is mentioned. It's mentioned in here. If you cannot see it, then you have a problem. The line is the line we're dealing with is cutting only the y-axis, so the x-axis is going to be mentioned. Therefore, cannot use any of those because any of the two, both of them, in fact, have got x and y variables. But the equation that we're going to find the inequality, we're just dealing with the y-axis, which is cut. This line is cutting the y and the x. That's why the equation has got both. This line also is cutting the y-axis as well as the x-axis. That's why the equation that we used that x and y variable. But this one here is cutting only the y-axis, meaning the inequality should only contain the y-axis. Again, you can pause the video, write those down, because I'm going to wrap as I get to question to equation 3. So like I've said, the third inequality does not need any of the general formula. What we're going to do is we're going to say which axis is cut. The axis which is cut is the y-axis. The axis here which is cut by this line shaded downwards is the y-axis. So we are going to say that the y-axis is cut at what line? 0. The y-axis is cut at the line 0. So if the line was drawn passing through point 2, we're going to say y is cut at 2. If it passed through point 3, we're going to say the y-axis is cut at 3. If it was to be drawn vertically like this, we could have said the x-axis is cut at 2. If it was to be drawn like that, we would have said the x-axis is cut at 3. Because this line is passing through the x-axis 0, as I said, the y is cut at x-axis, at the point 0. But which symbol did they use to shade downward? Just ask yourself to say this. The ones that are for the region that we are describing here as the question tells us is region. Remember, every time you want to substitute the y, the equal sign with the inequality sign, you have to test using the points that you identified. So the point that we identified through and through is 0.5, which is half, 0.5. All right, but look here, this is a value of x, this is a value of y, but in here, there is no x variable. Therefore, we're going to ignore this part, we just deal with that. So we're going to say 0.50, we have to compare the two now. After you substitute, do not put the sign, don't put the sign, the equal sign, because now we have to compare. Which one is bigger? Definitely this one is big. So because this is big, we're going to say the 0.5 is greater than 0. But look at the line. The line is not a hidden detail for us to maintain that sign. This is a full line, it's an outline. Therefore, it should contain or equal to. And the final inequality gets to be y is greater than or equal to 0. So giving the summary of what we've looked at, the three inequalities that were used to draw these the lines were: number one, the first one here, we found that y is greater than. I haven't written them down. Let me just check through. Okay, this point here is 0.5. So yeah, it's less. So y is less than or equal to x plus 1. This is the first inequality. Some of us who know these things, you can just look at it like the way I just looked at it, and I can tell the inequality. But definitely the procedure that I followed in my head is the ones that I showed you, but except that at a faster rate. Then the other one is this line. This is the first line whose inequality is that. Then this equation 2, what's the name of the equation? The equation is equation 2 is y. Okay, so definitely it's still small. No, the equation 2, because now the gradient is negative. So even if I subtract, it is still less than or equal to negative x plus 2. I believe these are the inequalities that we found. Then this one here, the inequality number 3 is y is greater than or equal to 0. Therefore, these are the inequalities that we were told to find. All right, mathematics is very easy. What makes it difficult at times is because we get advices from the people that have failed before. If someone has failed something, you can't get an advice from them. Then the other thing is the perception that we have towards maths. No, maths, someone told me it's a difficult mathematics. It's a difficult course, difficult subjects. Because of that, you feed your, what you tell your mind is what is who you become. You become of what you feed also. If you feed